cylinders. This is our goal today, is to make sure that we know how to find these items. So we're going to start off with some vocabulary. We'll start off with the volume. It is the measure of the amount of space contained in a solid. If we were to talk about the room that you're in, that you're watching this in, if we were to talk about the floor, the carpet that you might be on, and the paint on the walls, and maybe the ceiling tiles that are in the room that you are, those would be things that would describe for me the surface area. If we were to talk more about the air that's in the room, that is the amount of volume contained within the room. We measure things in cubic units, so the units are going to be cubic. So we just say these are cubic units, such as centimeters cubed or feet cubed. We pronounce this cubic feet and cubic centimeters. These are going to be the units that we use. To talk about that, we talk about how many 1 centimeter cubes fit to the right rectangular prism. So that means that we look at the base, we look at 1, 2, 3, 4, 5, 6 across by 1, 2, 3 deep. That would give us 18 in this bottom row here. And you can think of this as an office building, and a manager is trying to figure out how many people he can fit. Maybe he can fit 18 cubicles on the bottom floor. If all of a sudden he knows that he needs to have more people, maybe he'll rent the second floor as well. So you'd have another 18 up here, or we take the 18 times 2. That would give us a total of 36 cubes, or 36 cubicles, on the prism right there. How did we arrive at this? Well, we basically found the area of the base, which was the length times the width. We multiplied that by the height, how many levels this is. If this was an office building, find the area of the bottom floor and multiply it by the number of floors that we have. One word I wanted to talk about just really quickly is the word right. When you tell with a right rectangular prism, that just means that there's going to be a 90-degree angle between the base and the height of your cylinder. That's going to form a 90-degree angle. There's also something called an oblique cylinder, which what that means is that there's not going to be a 90-degree angle. This will either be more or less. This might be like 110 degrees in here, which makes this thing kind of lean. You can think about it, your obliques are actually the muscles in your abs that when you lean to the right or lean to the left, those are the muscles that are used. So it kind of makes sense why the obliques is something that just means that you lean either to the right or left. In two-dimensional, you could talk about a rectangle being having a right angle here. And if you look at a parallelogram, it's basically like an oblique rectangle. It's just leaning to the right or to the left. So the terms right cylinder and oblique cylinder, kind of important terms as we talk about this. They'll throw in the word right every so often. So using this idea of finding the area of the base, multiplying it by the height, it kind of tells us this here, that if the B is the area of the base of the right rectangular prism and H is the height of the solid, then the formula is just going to be V equals capital B times H. Remember, capital B just means we're going to multiply some of these things. So we'll talk about the base. That's going to be 2 times 4. So we say 2 times 4 on the inside here, and we're going to multiply that by the height. This building would be 3 high. I'm just going to multiply those together. I'll get a volume of 24 cubic centimeters. This building, volume equals base times height. The area of the base would just be 3 times 12. And I'll multiply that by 8 high. When I multiply those, I'll get 288 cubic centimeters, or that many cubes. Over here, same concept. Volume equals the area of the base times the height. So that would just be 10 times 30 times the height of another 10. So that would be a total of 3,000 cubic centimeters. Let's try this with another shape. You might calculate the area of this figure to the right. Notice it's no longer a rectangular base, but instead we'll actually calculate the area of the triangle first, and then we're going to multiply that by the height of the prism. So this is no longer a rectangular prism, it's actually a triangular prism. So the base is what is different. Again, we'll still use the same formula though. Volume equals area of the base times the height. In this case, it'll be 1/2. Our base here is 12 times 9. And then times the height. Our height between the two bases is going to be 16. That's that tricky h we've talked about in the past. When I multiply this together, pretty big number. This would be 864 cubic units. Okay. Now this stack here is going to be a little bit different too. What shape does this stack of crackers make? Well, that's going to be some sort of cylinder. And if we want to be more specific, we could probably call it a right cylinder. Probably going to make a right angle, like so, with this altitude. That would make this a right cylinder. Again, the same formula is going to be here. This time the base is just going to be equal to pi r squared. So we'll have a formula of basically pi r squared times h. So the shape of the base, some people would say it's a cracker or just a circle. So we have volume equals pi r squared times h. My height is obviously 2.5 centimeters tall. The problem is here that they gave us our diameter, so we'll have to make sure to divide that by 2. It's kind of a tricky thing that they'll throw at you sometimes. Don't worry too much about it. Just be careful when you're calculating things. So if I put these numbers in just like that into my calculator, I should get somewhere around 2.8 cubic centimeters. Okay. Some books will actually do this. They'll actually make a notation here that the capital H is then the height. It's the distance between your bases. I'm not really big on the capital H because generally speaking, capital letters, they tell us that we have to calculate something first. So I'm not really big on this idea. Volume is still going to equal the area of the base times the height. In this case, our area of the base is going to be 1/2 6 times 8. We're going to multiply that by a height of 20. 6 times 8 is 48. When we divide that by 2, we'd get 24 times 20. This would give us 480. This would be, again, cubic units. Because I don't really like this notation, I'm going to steer clear of this example. We'll move on to a different example instead. These two examples, we have a cylinder, and they might give you this in sort of a story problems. They might say, this is like a can of beans or something like that. I have no idea what this might be. This might be a slice of cheese, something like that, or a block of cheese. The idea here is you're still going to have to calculate the volume. So volume is going to equal the area of the base times the height. In this case, we have pi r squared times h. It tells us our radius here is 4. Our height is 10. So we have pi times 4 squared times 10. We'll round this to our nearest tenth, I guess, and we will get this many cubic units. For the cheese, again, volume equals the area of the base times the height. The base is going to be a triangle, so it's going to be 1/2 3 times 4. We'll multiply that by a height of 10. 3 times 4 is 12. Half of that is 6, so that would give us 60 cubic units. Be really careful with your units. Make sure that when we're finding volume, because it's three-dimensional, it should be cubic units. This also works with regular polygons. This would be called a pentagonal prism is what this is called. The volume formula is still the area of the base times the height. In this case, we have to use the 1/2 s times a times n formula that we've used in the past. The s stands for the side length, which is 6. The a stands for the apothem, which is 8. And then n is the number of sides of your pentagon, which is 5. This h, remember, denotes the distance between the two bases. In this case, the distance between the two pentagons, which I'm going to draw kind of in green here for each of these. Each of these lengths is the same. They should all be 4. 6 times 8 is 48. Times 5 should be 240. Half of that's 120. Times another 4 should give us 480. And now we have cubic meters. This is our volume. Today we're just taking a look at the volume of cylinders and prisms. Very similar idea to what we've talked about in the past. Basically the idea here, volume equals base, the area of the base times the height, the distance between the bases. Make sure you make note of the ideas between right and oblique polygons. They might come up at some point. Just the difference is with a right polygon, or right solid, there's going to be a 90-degree angles where it's perpendicular, the height to the base, where this is not going to be a 90 degree or not going to be perpendicular.